Hi everyone, so let's do today's daily Litco challenge question. I've also not seen this question before. I do not know what this question entails. Let's see the question. Minimum falling path sum. Minimum falling path sum. Okay, given n into n integers array of integer matrix, return the minimum sum of any falling path through matrix. So I will be given a matrix. Let's create a timer. Okay, so I will do it within 20 minutes. If I cannot do, then I look at the solution. Matrix 2, 1, 3, 6, 5, 4 and 2, 1, 3, 6, 5, 4 and 7, 8, 9, right? So given an n to n arrays of matrix, integers matrix, return the sum. Now a falling path starts at any element. Okay, so if this is the matrix that I'm given, then a falling path starts at any element in the first row and chooses the element in the second row that is either directly below or diagonally left or right. Okay, so suppose if I get this, then either 5 or 6 or 7, right? Diagonally left or diagonally right. Specifically, the next element from position row column will be obviously row plus 1, column minus 1, or yeah. Oh, that is what falling path is. Return the minimum sum of any falling path. Oh, I got it. So this is also a kind of dynamic programming question. I can do it by recursion. So what this is saying is I need to return the minimum sum, right? So what is the sum? Because there can be so many paths and I need to find out what is the minimum sum. So suppose if it is 2, 1, 3, so there can be this path, right? Either I can go to 2 or 3 or 1 or 3. And if I start from 2, then either I can go to 6 or I can go to 5. Right from 2, I can either go to 6, that is below, or left. In my case, left, there is nothing in the left, so I can go to 5. From 6, I can only go to 7 or 8. And from 5 also, I can do the same thing. I can either go to 7, 8, or 9. And similarly from 1 also. So if you can see, then there are so many paths, right? From 2, if I go, then there is one path, first path, second path, this is third, fourth, fifth. And if I go from 1, then there will also be similar path, right? But how will I know which gives me the minimum sum? I think that I need to go through the all paths. So if this is 2, then if I go through 7, 6 or 5. um, so if this is 2, then so I think that I need to go through all paths, and see the sum. So 2 plus 6 plus 7. So what is the sum? Sum is 6, 7, 8, 8, 7, 7, 14, 15, right? Okay, this is 15, so I can just say that minimum is 0 in the beginning. And okay, since it is sum is 15, so minimum will be 15. And now I can say 2 plus 6 plus 8. It is even greater, right? So minimum will be say 15, and then I'll say 2, 5, 7. Since it is 2, 5, 7, so 2, 5, 7 is 7, 8, 9, 9, 5, 14. So 14 is the minimum till now. And then I look at here this path, 2, 5, 8. Since 258 is the maximum, it is greater, so I'll not add this. Yeah, so that's what I'm thinking. I'll have to go through all the possible paths, and I think that I can do a memoization here uh because suppose if I know what is the sum, right? What is the value? Um, what is the value of the falling path? If I just start from 6, If I just start from 6, then what is the value of falling path? Suppose if it is x, okay, then suppose from 1 also, if I go through that falling path again, then I will not have to recalculate it, right? If I know it already. So yeah, I think I can do this question by recursion with memoization. So memoize like that. Whenever I get any memoization means whenever I get any value. Sorry, I'm distracted because the sun is setting. You can look as well. See there, sun is setting. Bye bye, sun. I don't know if you guys can see or not. Yeah, you guys can see, right? There is a lake, and the sun is setting above the lake. So that's why I was distracted a little bit. Okay. Um, I was distracted not because of the view, but because of the sun rays that is entering my eye. I mean, I cannot even like see the screen. What are the letters here? Because it is reflecting. I think it's on this side, but no, it's okay. Uh, so 136. Yeah, recursion with memoization, right? So if I encounter the same thing again, then I don't have to. I can just store that value and just return it immediately. I do not have to go through it again and again and again. But I think that even better than recursion memoization, what I can do is I can just do dynamic programming that way, because I do not want to do dynamic programming that I will just do this only, recursion with memoization only. Okay, I cannot see anything. Okay, increasing the brightness definitely helps. Recursion with memoization. You're about to go down the trees. Oh, are those birds? Are those birds or are those thoughts? Mm, yeah, I can do it in recursion with memoization. Let's first do recursion with memoization, okay, and then maybe I can do time programming after that. So recursion with memoization, what how I do is I just go through each and everything, and my base case would be while doing recursion, my I forgot of the timer. I just started looking at the sun and then forgot the timer. My base case, if I do not respect the timer, then why keep the timer? Base case would be when I reach the end row. Okay, so because I will just keep on adding and adding and adding, but when I reach the end row, then I will just return it. So when I reach the end row, I'll just return that value, because if I'm at 7, then the value will be 7 only, right? I cannot go anywhere else, so it will be 7. If I go and 8 will also return 8, 7 will also return 7, and 6 will return 6 plus 7, minimum of 6 plus 7 and 6 plus 8. So that is the base case, and uh, any function will return the minimum sum of the following path from that node. Okay, so 6 will return 6 plus 7, minimum of 6 plus 7 and comma 6 plus 8. If it is 2, 1, 3, 6, 5, 4, 7, 8, 9, then there are two following points with same 4, 4, 5, 8, 5, 13 here. So this is how I do recursion with memoization. And recursive, that would be this only. Row column will be row plus 1 column minus 1 plus row plus 1 column, row plus 1 column plus 1. So let's do it. Okay, recursion node. So any recursion function, what it will return is recursion function. I mean, doing recursion with memoization is easier because you just have to do this, right? Row column, row plus 1 column minus 1, row plus 1 column, this one. I do not have to think about the, I mean, if I'm doing from bottom to top iterative method, then I will have to think about the order as well. I know that I will start from the base, but I will have to think of the order, but this is much easier. Though the logic is same. Um, Function recursion node. So, oh, node. This is the base case, right? Otherwise, I mean, if it is at the end, then I'll do this. Otherwise, down, left, and right. There will be 3 values, right? So down will be row plus 1, row plus, what will be the down be? If this is row, then it will just be row plus 1 only. I guess what I can say is method minimum of this is down, right? And this is down left, down and left. Left means column minus 1, and right means column plus 1. minimum of down left or down right, but um, if row is, I mean, if it is in boundary, right? If it is boundary condition means if it is less than 0, or if row is greater than matrix dot length greater than or equal to matrix dot length, or if column is less than 0, or if column is greater than or equal to matrix dot length, right? It means that it is out of bounds. Then what should I return? Minimum. Then I should return some large value, isn't it? Because if I'm at 4 and then minimum, because I cannot do that as minimum. Mm, number that maximum value. Matrix I, J. Oh, it will be up to 100, right? So it means that I can just say, so return 101, so that any number will be, even if it is 10, then the minimum will be 10 only. This is equal, nice. Uh, and then recursion. I will have to start from 0, 1, 2, right? So it will be like math dot minimum of, because I will have to start from all the all the points, right? So it will be, it should start from 2. So then this recursion function should also be called from 2, from 1, and from 3. Whatever is the minimum will be the value, isn't it? Because this recursion function, the logic is only for the falling path. So let's first of all, this will return me first row, first column, right? First row, first column, and then first row, second column, first row, third column, first row, fourth column. So it will give me all first row, all columns, and at last return raise. Okay, and in this recursion, what I have missed each has map like save gas. So cast value. Hmm. for this row and for this column. So it should be a string. If this is present, then I'll just return this. Oh, I also need to add the value actually, because suppose if it is 6, then it will be 6 plus 4. Yeah. I'll go through this again. So result is 101 in the beginning because I want to make it minimum. So since the maximum value is 100, so whatever the value of this recursion is, it will be the result, right? So and I'm going from 0 to, and from this first row, first column to the last column. So from 0 to last column, j plus plus, and then whatever will the value is, that will be the my result, right? The minimum of 0 0. And recursion, this will return me if this is 2. Suppose if this is 1, then this will return me, it will go uh, it will go through all the values and then return the minimum, right? So it will do, if it is giving 1, then it will be 1 plus 6, 1 plus 5, 1 plus 4, right? Because this down will give me 1 plus 5, and then this will give me 1 plus 6, and this will give me 1 plus 4. So this 5 will give me 5 plus 7, and at last 7 will give me uh, just 7 only if it is at the end. Oh, length minus 1, I guess. If row is at the end, right? So if row is less than 0, if row is greater than or equal to, column is equal to greater than or equal to, column is less than 0, then return 101. If it is equal to matrix at length, it means that it is at the end. If it is at the end, then I'll just return matrix row column. 47 disk is 3, only 3 has failed, okay? So for this one, why is not working then? 82, 81, and then 69, 33, right? So it will be 82 or 81. So if I go through 82, then it will be 69 plus 33. 82 plus 69, 82 plus 33. Expected is 114. Output is 101. Interesting. Why is it calculator? I'm just using calculator and doing 82 plus 18, 82 plus 69 and 82 plus 33, 115, and 81 plus 69, 150, and 33 plus 81, 114. Yeah, answer should have been 100. Where is 101 coming from? I do not even understand that. 0, 114, 1, 114. Oh, what? Shit. What am I doing here? So the mistake that I did was this one. Number the maximum value. It's fine that I'm comparing this one, right? Because this is just the value of a row. But this is the value of the sum. Sum can be anything. Now 48. Now two test cases are failing. And output is 201, but expected is 10,000. How can I use this example here? I don't know, like what is wrong? Two test cases are failing, so what is wrong? Why is output just 201? It's already 6 p.m. The new late code question has arrived now. Software is deleted in retrospect. Uh, there are so many columns. There are so many rows. I think something is wrong with this one. Oh yeah, yeah. This is not good. Time limit exceeded. What I can do here is, yeah. So this was the problem, and what I can do here is, I think um, this one, it is always, um, I think this row and column, this will always be there. I think what one optimization we can do is, if I don't need to go to another branch if it is already, you know, uh, from 2 to 6, right? So 6. I was looking at sunset, now it is on setting and everything is like it's already dark, and this was like 6:12. This will be some optimization. I mean, obviously I can do dynamic programming bottom to up, but there should be some optimization here. So what I'm doing here is from bottom, I'm going to 2, and then whenever I get a 6 value, uh, and then I'm going to 5. So from 5, I'm going to 7. From 5, I'm going to 8 again. Yeah, this is very, very bad solution. Too bad. Let's optimize bottom-up dynamic programming. Yeah, I should have turned on dynamic programming in the beginning only. This one last test case is fading again and again and again. This is what I did, approach 2. Yeah, from it selling the top 2, this is what I did, right? Math at minimum. And then this is the base case, return integer than maximum value. And check if we have reached the last row. Check if results are calculated before. Calculate the minimum falling path, left, middle, and right. And yeah, actually it is the same thing. Yeah, instead of doing this, what I could have done is I did not have to add everything, right? I could just have added at the last. This is the only difference, otherwise everything is the same. This got accepted, but why did mine not? It is the same. I'm doing the same thing. Now the code is exactly the same. Okay, I do not even need to do this because I do not need to check the column row because um, It will not go. Why do I not need to check the rule? Anyway, it's like everything is same, right? I think it's just Java and or what I can say is if cast value, then return cast value. If it is equal to undefined. What the hell? That was the reason. Because yeah, that was the reason actually. This is not equal to null. This was the reason that I was not able to that my answer was not being accepted here. Because sometimes this cast value can be 0, you know. So if it is 0, then it will be false. So it will just continue doing this. I should always remember doing this, is not equal to undefined. What then? So the main problem here was things that I need to be all out of is, so suppose if the value is 0 and if I say if value 0, 1, 2 and it can be undefined, right? You can say map key. So if there is some map and then there is some key, okay? So how will I distinguish between 0 and undefined? If I say that, okay, if 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 the value is present in the map, stored in the, if there is, if there is the key in map, then do something. If I say this, okay, so I will just consider that, okay, this map key will be, if there is value, if there is key in the map, then do something, right? So if I just do this only, then it will be, if map key will return 1, then it will do something, right? If it will return 2, then it will do something. But if it returns 0, then it does not do anything. So I should always check if map has key. Dot as. Because this was the way that I was checking if it has if this returns 0, then it will be like undefined. Is not equal to undefined. Any other way to do this? Anyway, so this is the main mistake that I did. I did not check if it is undefined or not. I should check if it is undefined, if it is not equal to undefined or not. But then otherwise, I mean, the exact same solution. This solution and my solution is it is the exact solution. Should always think. I should never forget about this because I always miss this thing. If it is 0, then it will not do anything. It will not go inside. The value is 0, even if the key is present. Okay, everyone, thank you so much. Let's look at today's daily LeetCode challenge question. because it's already in, because new question comes at 6. What? I've already solved it. Why is it saying, uh, why is it not giving me to, letting me go to new question? Sum of sub array minimums. Okay, I will do this again. I'll stream immediately.